All right, so this is part 3 of your chapter 6, and this is dealing with section 6.3. So this is chapter 6, activity 3, and it is dealing with elastic and inelastic collisions. So a collision, when you hear that word, you probably automatically think of a car crash, or you probably think of a collision in like a sports world or anything like that. But as you go about your daily routine, you probably see this multiple times a day and you just don't think about it. And so when we have a collision, we have objects that are colliding and sticking together, and so that they travel together after the impact. And so an example of this is like an arrow and a target. And so if you look on page 222, figure 610 gives you this example, and it shows the arrow sailing forward collides with the target at rest, and so it's going to cause a collision. Okay. We're also going to take into effect total momentum, knowing that momentum is going to remain constant. However, we have to factor in kinetic energy in order to know that there is some form of motion taking place in order to describe what this concept of elastic versus inelastic is. And so when you have two objects colliding and they move past one another as one mass, like the arrow and the target, the collision is called a perfectly inelastic. So we can also use this example with a meteorite. When it collides head-on with Earth, it becomes buried in the Earth, and the collision is nearly perfectly inelastic. So meaning that there's not much that takes place after it kind of gets stuck in there. There's no debris or things of that nature. Perfectly elastic conditions are easy to analyze in terms of momentum because the objects become essentially one object after the collision. The final mass is equal to the combined mass of the two objects, and they move with the same velocity after colliding. So we have another formula, okay, that we are going to use for perfectly inelastic collision. And here it's super tiny here. Refer to page 223 in your textbook. And basically you're going to have mass and velocity, and we're going to add those together to another mass and velocity, and we're going to look at them in terms of final. Okay, so we can do this with cars, and we can do this with what happens after the collision. And so if we continue through the textbook, it's going to give you some problems. And this problem is dealing with a luxury sedan. So it's sample problem 6E. And so it's also here on slide 27 for you. So you can kind of work through that and use that equation by plugging in your masses and your velocities to find the final velocity. There's also another example with an empty train car that you can look at. So please take a look at this one here on slide 28, as well as looking in your textbook for extra support. Okay. When we deal with inelastic collisions, we're looking at kinetic energy, how it's not constant. So there's some energy converted to sound energy and internal energy. So like something that's going to be a deform. And so these are ones where their kinetic energy doesn't remain constant when the objects collide or stick together, and it's converted into something else. And so we use the term elastic versus inelastic. And so because we're referring to something that is going like retain its shape versus something that'll be deformed, if that makes sense. And there is a problem on page 225 in your textbook, which is also here on slide 30 for you to practice. And the solution is on 225. And it works you through that problem. So please take advantage of that, okay? As you move on through the section on page 226, it's going to deal with elastic now. So this is where we have the two objects colliding and they're returning. So we've got something happening here that is a separation. So we've got objects moving separately. You've got collisions that are going to be neither elastic nor perfectly inelastic. So they're kind of a person of their own, and they're either converted into sound or some sort of internal energy. And so, of course, we get to have another equation for this. And so if you look on page 227, since this is kind of messed up here with boxes, those boxes just should be plus signs and equal. So please refer to 227 in your textbook for that. Here's an example problem, which is on page 228 with a solution, as well as looking at some of the other practice problems. And that is it for chapter 6.